9.2, question 14. The following pattern continues. Figure 1, figure 2, then to figure 3. And we see there's a number of squares here, a number of squares here, and finally a number of squares here. It says make a table of values showing the figure number, 1, 2, and 3, and the number of squares for the first 6 figures. Well, we have the first 3 figures here, and I've actually taken the liberty of drawing a table of values here with the first 6 numbers for figure number here. And we could probably count the squares in figure 1 and see that there are 4 of them. And I'll just take my pen here and draw 4 for my figure, a number of squares. In figure 2, we have 3, 4, 5, 6, 7. Then we have 10 in figure 3. Well, if we look here, what are we actually doing with this pattern? So we can see here that our base was 1 here, and our base was 1, and our roof here was 2. And then I added 1 on to the end, so 1 more onto the bases, and 1 more onto the roof. Then I added 1 more onto the bases, and I added 1 more onto the roof. So each time I go to a different figure, I'm actually adding 3 more squares onto my my pattern. So if I take that for granted, the number 4, the fourth figure would be 1 more here and 1 more here, and then 1 more to the roof, which makes 13 squares in total. And then again, I'd go 16 here, and then finally 19 squares for my 6th figure. It says, question B says, write an expression showing the number of squares in terms of the figure number. So I have to say, what is the relationship of this number to this number? And let's give this a variable here. Let's give this an F, and let's give this an S. Well, if I take my figure number and make an equation with, I'm actually making an equation instead of an expression. I'm going to create an equation here. It says expression, but we will see the expression over on this side of the equation that represents the relationship. Well, I'm looking at it and I'm thinking, well, did I take my figure number and just add 3 every time? Well, in the first one, if I take my figure number 1 and add 3 to it, 1 plus 3 is 4, and it works. I'm like, well, that must be it. But when I check my second one, 2 plus 3, and see if I add 3 more to this, it doesn't give me the number of squares. So using just a constant or a plus 3 does not work. So then I think, well, maybe it's a coefficient. So maybe I multiplied 1 by 4 to get this number. So I say the figure number times 4. Well, it worked for the first one, but again, figure 2 times 4 does not give me 7. So multiplying does not work by itself either. So then what I have to do is I have to kind of play with a combination of both a coefficient and a constant. And in this case, I'm going to say, okay, well, what if I just multiplied this instead of multiplying by 4? What if I multiplied it by 3? So 1 times 3. How would I get to 4? Well, I have to multiply it by 3 and then add 1 more. So it worked for that first one. Multiply the figure number by 3 and add 1. I check it out down here. Well, it's 2. So if I multiply this by 3, I get 6. Plus 1 more, I get my 7. Well, it worked again. That's great. So then I try it again. I multiply the figure number, in this case 3 by 3. I get 9. Plus 1 more, I get 10. 4 times 3 is 12. Plus 1 is 13. And consistently, that pattern works. Multiplying the figure number by 3 and adding 1 more. So algebraically, what we use is we use the coefficient of 3, 3 times the figure number, plus 1. And that will equal the number of squares. So really, this is an algebraic equation, but this is the expression that shows the relationship between the figure number and the number of squares. Question C says, how many squares would appear in figure 20? Well, I can write figure 20 here, and I could figure out, well, how am I going to do that? I could extend this chart all the way down from 6, 7, 8, 9, 10, all the way down to 20 and keep filling it in 3 at a time, but that would be a waste of time. Now that I have this formula up here, I could simply take my F amount, in this case now it's 20, and substitute it into my formula. So 3 times, up here it was F, but instead of F I can say 20 now. 3 times figure number 20 plus 1 should equal my number of squares. So order of operations says do this first. It's 60 plus 1 will equal my number of squares, or there will be 61 squares if they're in figure 20. So I can put 61 squares. How many more squares are in figure 20 than figure 10? Show 2 ways to find your answer. Well, I know how many are in figure 20, but I don't know how many are in figure 10. But I can kind of use the same formula here and kind of cheat and put 10 up here. I'd say, okay, this is now figure 10. So 3 times the figure number, figure 10, plus 1. 3 times 10 is 30, plus 1 is 31. So my number of squares here would be 31. And the question D says, how many more squares are in figure 20 than figure 10? Well, there are 61 squares in figure 20, 31 squares in figure 10, so therefore there are 30 squares more. And that's question 14.